Hello, my name is Taylor Bacher, and this is Lab 1 Constant Velocity. The purpose of this lab is to observe the motion of an object at constant speed, use a computational and experimental model to predict and analyze an object's motion, and to compare the data between the two models. The results were that after the first few frames, the object's observed motion deviates from its predicted motion. Let's look at some background information. When the net force on an object is zero, the object has a constant velocity. This is from the velocity update formula, which is derived from Newton's second law. When net force is equal to zero, the final velocity and initial velocities are equal and are therefore constant. We can also predict the position of an object using the position update formula, which is also derived from Newton's second law. When the net force is zero, we can also say that air resistance and friction are negligible. Now let's look at the experimental model. To set up the experimental model, the object was weighed to assess its mass in kilograms, the distance the object would travel was measured and marked, and the object was laid on a flat, even surface. To start the recording, the object was pushed, and the object's motion was tracked using tracker software, and its initial conditions are below. We observe the system to be the object, and everything else is the surroundings. The results from the experimental model show that the object's velocity was observed to be changing constantly. Therefore, this object does not have a constant velocity, and there is not a net force of zero. This could be due to air resistance, friction on the table, and other human error. Now let's look at the computational model. To set up the computational model, GlowScript was used to track the motion of a theoretical object of the same mass and the same initial conditions. The system and surroundings are the same in this model as were the experimental model, and the velocity and position update formulas were used within a while loop. The results of the computational model show that velocity is constant at 0.19 meters per second. Therefore, it is a net force of zero because the final velocity is equal to the initial velocity. In this case, air resistance and friction are negligible. When comparing the data between the tracker and GlowScript methods, we see that the tracker data deviates from the GlowScript trendline after a couple of milliseconds. This means that the tracker data did have forces acting upon it and did not have a net force equal to zero. What if we observed our data in the negative x direction instead of the positive x direction? Well, since velocity is a vector, meaning it contains a magnitude and a direction, this means that position is also a vector. In the positive direction, an object is moving to the right or away from the origin. And in the negative direction, the object is moving towards the left or back towards an origin. So in this lab, the magnitudes of the values would stay the same, whereas the sign would be the opposite. This also means that velocity values become more negative as well if position values become negative. So what does this all mean? We know that zero net force could mean either two things, that no force acted on the object at all, or that the forces were equal and in opposite directions. Well, because the tracker data show that there was a net force not equal to zero, we can't exactly conclude what those forces were, but we can definitely say that the forces were a force applied in the positive x direction, the force of friction in the negative x direction, the force of gravity and then pulling in the negative y direction, and then normal force pulling in the positive y direction. After further analysis and comparison of the data, it can be concluded that the object in our experimental method did not have a constant velocity and did not have a net force equal to zero. This could be explained by either air resistance, friction, and possible human error, like how our object was not completely round, or that measuring could have been off. Thank you.